Hi everybody. I just wanted to talk about Chapter 10 and hypothesis testing regarding a parameter. So Section 10.1 is about the language of hypothesis testing, and so objectives in this case will be determine the null and alternative hypothesis, explain type 1 and type 2 errors, state conclusions to hypothesis tests. So let's look at each one of these objectives. So the first objective is determine the null and alternative hypothesis. So a hypothesis is a statement regarding a characteristic of one or more populations. So something that that's sort of assumed to be true. In this chapter, we'll look at hypotheses regarding a single population parameter. So we'll look at the population proportion, the mean standard deviation, and in subsequent chapters we'll look at what happens when we're comparing two different population parameters if we have more than one sample. So let me give you an example of claims regarding a characteristic of a single population. So here's some examples. So for example, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. According to a study published in March of 2006, the mean length of a phone call on a cellular phone was 3.25 minutes. A researcher believes that the mean length of the call has increased since then. Right? So the idea in this case is that the hypothesis would be that the mean length is 3.25 minutes, and you're testing to see whether that mean length has increased or not. Here's another example. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle is 0.23 ounces. With new equipment, the quality control manager believes that the standard deviation has decreased. So in other words, what that means is, if you put wine in the bottle, on average, the standard deviation or the deviation in the volume of the wine would be 0.23 ounces. And so basically what you're saying in this case is that the deviation has decreased, and so there should be less variation in the volume of wine in each bottle. So each bottle should be more or less, the volume should be closer than it was before in each bottle. One word of caution is we test these types of statements using sample data because it's usually impossible or impractical to gain access to the entire population. If the population data were available, there'd be no need for inferential statistics. So basically what this is saying is that we're trying to draw conclusions based on a sample, and based on how likely it is that that sample is correct, we can draw conclusions from that. So hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. So here are the steps in hypothesis testing. 1 is make a statement regarding the nature of the population. 2, collect evidence, sample data to test the statement. 3, analyze the data to assess the plausibility of the statement. So the null hypothesis, denoted by H sub 0, is a statement to be tested. The null hypothesis is a statement of no change or no effect or no difference, and is assumed to be true until the evidence indicates otherwise. So we're assuming that the null hypothesis indicates that the parameter we're looking at, whether it's the population proportion, the mean, or the standard deviation, is equal to something, and that it is not changing. The alternative hypothesis, on the other hand, denoted by H sub 1, is a statement that we are trying to find evidence or support for that either the parameter that we're looking for is increased or decreased, or is at least changed in some manner. In this chapter, there are 3 ways to set up the null and alternative hypothesis. The first one is that the parameter is equal to some value, and the alternative hypothesis is that the parameter is not equal to the value it was before, it's somehow changed. The second way to do this is called a left-tailed test. So the first one is the parameter is equal to some value, and the alternative hypothesis is that the parameter is less than some value. And then the third way to set this up is that with the null hypothesis, the parameter is equal to some value, And the alternative hypothesis is that the parameter has increased, and this is sometimes called a right-tailed test because you're looking at the right end of the distribution. I'll give you some examples here in just a minute. But so there are three basic things that can happen. Either the thing that you're looking for has changed, it's not equal to the value it was before, it's either less than the value it was before, or it's greater than the value it was before. So in other words, the null hypothesis, again, is a statement of no change, right, or status quo, or no difference, and always contains a statement of equality. The null hypothesis, again, is assumed to be true until we have evidence to the contrary, so we seek evidence that supports the statement in the alternative hypothesis. So here's an example. For each of the following claims, determine the null and alternative hypothesis and state whether the test is two-tailed, left-tailed, or right-tailed. So in 2008, right, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So the in this case, the null hypothesis would be that the percent of Americans who volunteer is equal to 62%, and then the alternative hypothesis would be that the percentage of volunteers is not equal to 62% anymore because it's changed. For part B, it says, according to a study published in March of 2006, the mean length, or the average length, of a phone call on a cellular telephone was 3.25 minutes. Right? A researcher believes that the mean length, so the average length of the call, has increased since then. So in this case, the null hypothesis would be that the length of a phone call has remained at about 3.25 minutes, and the alternative hypothesis would be that the length has increased, right? So that would be a right-tailed test. And then part C, it says, using an old manufacturing process, the standard deviation of the amount of wine put in a bottle is 0.23 ounces. With the new equipment, the quality control manager believes that the standard deviation has decreased. So the null hypothesis in this case would be that the standard deviation, so sigma, is equal to 0.23, whereas the alternative hypothesis would be that sigma is now below 0.23, so that would be a left-tailed test. So here just to state these again, right? So in this case, the null hypothesis would be that the percentage of Americans is equal to 0.62. The alternative hypothesis is that you have a two-tailed test, indicating that the proportion is not equal to 0.62. Part B, so the null hypothesis again is a statement of no change. That would mean that the mean length remains 3.25, but in this case the alternative hypothesis is that the researcher believes that the mean call length has increased from what it was of 3.25, so since the arrow is pointing to the right, this would be a right-tailed test. For C, again, the null hypothesis would be that the standard deviation is equal to 0.23, and the alternative hypothesis would be that in this case, sigma is less than 0.23, so since the arrow is pointing to the left, that would be a left-tailed test. So that's the first thing we want to talk about, is the three types of hypothesis tests you can do. Now, as far as objectives 2 is concerned, we want to explain basically the difference between type 1 and type 2 errors. So if you think about it, there are four outcomes that can happen from a hypothesis test. One is that you reject the null hypothesis when the hypothesis is actually true, and this decision would be correct. And so rejecting the whole null hypothesis basically means you're accepting the alternative hypothesis. If you do not reject the null hypothesis when the null hypothesis is true, so this decision would be correct. But there are two types of errors you can make. One is rejecting the null hypothesis when the hypothesis is actually true, so that would mean your sample that you've taken doesn't really tell you really what's going on. This is a type 1 error. And then the other type of error would be when you do not reject the null hypothesis when the alternative hypothesis is true. And so that would be an incorrect decision. And so this is called a type 2 error. So there are two types of mistakes you can make, a type 1 error and a type 2 error. So here's an example. Let's look at these examples. and what it would mean to make a type 1 error and a type 2 error. So in 2008, 62% of adult Americans volunteered their time for charity work. A researcher believes that this percentage is different today. That's part A. And B is, according to a study published in March 2006, the mean length of a phone call is 3.25 minutes, and a researcher believes that the mean length of a call has increased since then. So for part A, a type 1 error would be made if the researcher concludes that the proportion is no longer equal to 0.62 when the true proportion of Americans is actually equal to 62%. A type 2 error is made if the sample evidence leads the researcher to conclude that those who participate in charity work is still 62% when in fact the percentage is different from 62%. For part B, a type 1 error would be if the sample evidence leads the researcher to conclude that the mean length of a phone call is greater than 3.25, when in fact the actual average length of a phone call is still 3.25. And a type 2 error occurs if the researcher fails to reject the hypothesis that the mean length of a phone call on a cell phone is 3.25 minutes, when in fact it's longer than 3.25 minutes. So alpha is what's known as the probability of a type 1 error, and beta, we're going to use that to talk about the probability of a type 2 error. We're mainly going to talk about type 1 errors. To talk about type 2 errors, we'd have to talk about stuff in 10.6, which we're going to skip. So the probability of making a type 1 error, which we'll denote by alpha, is chosen by the researcher before the sample data is collected, and the level of significance alpha is the probability of making a type 1 error. So the probability of a type 1 error increases, the probability of a type 2 error will decrease, and vice versa. The last thing we want to look at is stating the conclusion to a hypothesis test. So although you might be able to determine whether to reject or accept the null hypothesis, you really want to state that in words so other people can understand what you're saying. So we never, as a word of caution here, I guess you should never accept the null hypothesis, because without having access to the entire population, right, we don't know the exact value of the parameter stated is null. Rather, we say that we do not reject the null hypothesis. We do not reject the null hypothesis. This is just like a court system. We never declare a defendant as innocent, but rather we say not guilty. So here's an example here. So according to a study published in March 2006, again, this is the cell phone example, the mean length was 3.25 minutes. And a researcher believes that the mean length of a call has increased by then. So suppose that the sample evidence indicates that the null hypothesis should be rejected, state the wording of the conclusion. And then B, suppose that the sample evidence indicates that the null hypothesis should not be rejected, state the wording of the conclusion. So A, in this case, you would say that the statement of the alternative hypothesis is that the mean call length is greater than 3.25 minutes. Since the null hypothesis is rejected, you would say there is sufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. For the second example, you would say that the sample evidence is consistent with the mean length of equal to 3.25 minutes. Okay, well that should wrap up section 10.1, so the next thing we'll look at is section 10.2 on hypothesis tests for a population proportion.